Hey team. So at this point, you have been playing with the drink machine and learning a little bit about how it works. And if I had to guess, you've been spending quite a bit of time doing some guessing and checking with the weight commands on drink machine in order to get the right volume, the right temperature. And so in this video, I want to show you some other ways that you can more systematically do pieces of this task using some code to help you out. So what I've set up on the screen right now is you can see two steps. What I want to do is fill the container for a little bit of time, find the volume, then fill the container for a little bit longer, find the volume there, and then based on that, I then have 2 points that I can use to write a linear function, and then use that line, point slope form, or y equals mx plus b, in order to actually calculate the amount of time I need in order to fill that container to a specific volume. Because really that's the guessing and checking that's happening right now. I know I need to fill this to 500 milliliters, and I'm guessing and checking to try to find the time that I need for that. So this, using some math, will help us be a little bit more systematic about it. So let's get to it. I've written the code to do this. You can see this first part, I start the container, I wait 2 seconds, I stop filling the container, I print out the volume. And then I do that a second time, and that'll give me 2 points. So let's run the code and see what values I get. And so here in the console, you can see I have 314.5 and 628.5. I'm going to copy those. And I have one of my favorite tools open, Desmos, just so we have those 2 bits of information somewhere. So these values are my volumes. I want this to be, this is kind of the input, because I want to be able to tell it the volume, and I want a function that will give me the time that I need to use in order to fill the tank to that volume. So these are going to be my inputs. I'm going to make those my x values. So the first thing I'm going to do is I'm going to put in 314.5 for my x, and then for my y, I'm going to put in the 2 seconds, because initially I filled the container for 2 seconds. So that's my first point. My second point, I'm just going to use the volume of 628.5 milliliters and the time, which is the total time of 4 seconds. Okay, so you can see I have those 2 points on the screen. It's a straight line. How do I know that? Well, I really don't. But if you think about it, I can assume that it's a straight line and just see if that does a good job of accurately modeling the data of this drink machine. That's kind of the engineering process here. You make some assumptions, you test those assumptions to see how good they are, and if they work well enough for your purpose, go ahead and use those moving forward. So I now want to write an equation of a line through these 2 points. I'll just remind you of this formula, which is the point slope formula. I love the point slope formula because it's the fastest way that you can actually write a linear equation when you know 2 points. The one thing missing in that top formula is the slope. But the slope formula is what it's been ever since you first learned it in Algebra 1, just y2 minus y1 over x2 minus x1. And we can calculate these within Desmos or within a program. So now I have my slope, my m, and now I can just write an equation for that line. So from this equation, you can see that I now have a straight line that goes through both of those points. And what's kind of cool about this is if I take a point and drag it all along that line, I can use that to tell me what time I need for any volume. So if I want to go for 500 milliliters exactly, I know now that I need to use exactly 3.182 seconds. Let's try that and see how well it works. So we'll go here. I'll change this to 3.182 because that's 3,182 milliseconds, and let's try it out. And look at that. So we get 500.545 milliliters. Not bad. Do we care about that 0.545? Not really. How do we know that we don't care? I'm telling you right now, that is close enough for our purposes. If you look at the assignment that I've given you, I actually ask for you to be within 5% of the target volume, so this is pretty good. So I am happy with that. Now, we don't want to always have to go to Desmos to get what that number is, because we want to automate as much of this process as we can. So let's write a function that tells us what that time needs to be given the volume that we want to put in. And this is one of the reasons I actually really like point slope form, because when you do the calculations for point slope form, you're actually setting yourself up really nicely to write a single function that gives you from the input value and output value that relates to what you put in. So this y, this represents the time. I can simply take this, move it to the other side, and add it in, and it's the same equation. And it has y, which is my time, as the output, and on the right-hand side of that equation, it has volume as the input. And so I can write a function that does exactly this calculation using the 2 points that I gave it in the beginning. So let's write that function. So now I have the same calculation that I did in Desmos, but I'm just doing it here in the simulator, and I'm returning the output volume. So let's try to use that time now, that function, in my code. So I call my function, and inside I'm going to put the 500 milliliters as the volume. And then I'm just going to change this to large volume time, because that's the right time to fill it. And let's run the code. Okay, so I'm getting 1.285 as the milliliters, and I am realizing that the reason this is happening is that I have given it, my input values were in seconds, but this wait function right down here is expecting milliseconds, not seconds. So there are a couple things that I'm going to fix up at this point now that I figured that out. Number one, I misnamed this. I should really call this output time instead of volume. So I'm going to make that output time. But because my data, my input data is in terms of seconds, not milliseconds, I have to take that number and multiply it by 1,000. So let's run it again and see how well it works. Okay, so now we can see that this is correctly filling to the volume we were looking for, 500 milliliters, because I made that fix. So that is one way that we can use some coding to make it so that we aren't manually guessing and checking to find that volume. So see if you can use this with some of the other volumes, perhaps, to make it a little easier for you. Good luck.